In the previous videos, we talked about using the concept of symmetric polynomials to solve some radical root equations. In this video, we will use the same concept to find the solution of one Diophantine equation. The source of today's question is from Harvard and MIT Math Tournament, November 2018, General Round, problem number 5. Here's the question. Find all possible integers n so that the square root of 100 plus square root of n plus the square root of 100 minus the square root of n is also an integer. Similar to what we did before, we do a substitution here by letting a be the square root of 100 plus the square root of n and b be the square root of 100 minus the square root of n. From here, we can get a squared equals 100 plus square root of n and b squared equals 100 minus square root of n, and which lead to a squared plus b squared equals 200 and a squared times b squared equals 100 squared minus n. And by the definition of a and b, we know a and b is an integer, so we let that integer be m, which means a plus b equals m. M is an integer. From a squared plus b squared equals to 200 and a plus b equals to 2m, we can easily get 2ab equals m squared minus 200. And from here, that means m squared equals 2ab plus 200, which is even number. That means m is an even number. So we do another substitution here by letting m be 2m0. Here m0 is also an integer. And we put 2m0 into the above equation, and we get 2ab equals 4m0 squared minus 200, which means ab equals 2m0 squared minus 100. And on the other hand, we also know a squared b squared equals to 100 squared minus n, and those two combined together, we have 100 squared minus n equals 2m0 squared minus 100 squared. We do a simple manipulation of this equation and get n equals 100 squared minus 2m0 squared minus 100 then squared, and which leads to 2m0 squared times 100 minus m0 squared. From this equation, we need to get numbers of m0 and n. To do so, we need to find out the range of m0 squared. First of all, apparently n is larger than or equivalent to 0, equal or larger than 0. That means 4m0 squared times 100 minus m0 squared is larger than 0, which leads to m0 squared equals or larger than 0 or equal smaller than 100. And on the other hand, we also know ab equals 20 squared minus 100, which is also equal or larger than 0. That means m0 squared equals or larger than 50. These two combined together can lead to m0 squared equals or larger than 50 or and equals or smaller than 100. And we know m0 squared is a perfect square between 50 and 100. That means the possible values of m0 squared could be 8 squared, which is 64, 9 squared, which is 81, or 10 squared, which is 100. So from here, we can have all the possible values of m and n, which are listed below. When m0 squared is equal to 64, n is equal to 9216, and m is equals to 16. When m0 squared equals 81, then n equals 6156, m equals 18. When m0 squared equals 100, n equals to 0, and m equals 20. The problem gets solved. Finally, we find 3 different values of n. To satisfy the square root of 100 plus the square root of n plus the square root of 100 minus the square root of n be an integer. Thank you.